So up till now, in two videos, we have covered our some main topics. Section 1.1 we have covered already, and section 1.2, which was like everything was about objective or testing and about the defect and failure. Now here, it is a really important topic as far as ISTQB foundation level exam is concerned, which is 7 testing principles. Like there are 7 testing principles which you need to keep in mind, and during exam you will get some questions about them, maybe one or two. So there are some basic testing principles. Like over the last 50 years, testing shows the presence of defects, not their absence. Like whenever you do the testing, you come to know that there are some defects in the code, but even when you say that your code is working properly, you haven't found any bug, you are never sure that there is no bug in the code, because like the duty of the tester is to find a proof as many defect as possible. But like it is not the duty of the tester to tell that there is no defect in the code. Testing can show the defects are present but cannot prove there are no defects. Testing reduces the probability of undiscovered defect. Like you do testing and you uncover as many faults as possible remaining in the software, but even if no defects are found, testing is not a proof of correctness. Even you haven't found any defect, still it is possible that there are some defects in the code. As I told you in the false negative, it is like false negative is the term, so it's possible that there are still defects in the code. The second principle is exhaustive testing is impossible. You cannot test your code for every possible value. Like for example, one of your parameters is I will say integer 16, so 2 raised to the power 16. I guess it will be if I say it unsigned integer 16, let's say, so 0 to 65535 test cases you have to write. It's never possible. You can never test anything exhaustively. Testing everything, all combination of input and precondition is not feasible except trivial cases. There could be some trivial cases. For example, you have two boolean values, so you can say true true, true false, false true, and false false. So there are some trivial cases possible in which you can test all the combinations, but exhaustive testing is never possible. Maybe in some trivial cases it's possible, but not in everything. Rather than attempting to test exhaustively, risk analysis, test techniques, and priorities should be used to focus test efforts. These all terms will be covered in the whole ISTQB in all upcoming chapters. We will see in detail. So since you cannot do exhaustive testing, you see that there could be some risks in this particular module. Test it as possible intensively as possible. Apply some relevant techniques. This we will also see in upcoming chapters. Do the prioritization. It is more critical system. Prioritize, run test cases on this first and then go to the second module. So you can prioritize your dependencies, but still exhaustive testing is not possible. The third principle is early testing saves time and money. This I have already told you. As early as possible, involve the tester in the process. Either it is getting the requirement draft, either it is of the system design, high level or low level, either it's coding. Involve tester as early as possible, because if he finds the defect in the requirement at an early stage, then it will not replicate to the high level design, it will not replicate to the low level design or even in the coding. So to find defects early, both static and dynamic activities should be started as early as possible. Static, we have seen that reviews, static analysis of the requirement or of the code without running it is static testing, and dynamic means you execute test cases. So it should be started as early as possible in the software development lifecycle. It will save your time and money. If you find a bug in requirement, it will take you less time and money to fix this bug. But if this bug is replicated, for example, on the code level, after system design, low level design, and in the code, then it will take a massive time and money to fix it. So early testing is sometimes referred to as shift left. Shift left means you have shifted your testing to an early stage. That means testing early in the software development lifecycle help reduce or eliminate costly changes. So like shift left is a clear term. Shift left means you are shifting your testing to an early phase, starting from the requirement. You are not testing it when your code is ready. No, start testing, shift left. Your testing should be shifted to left and start it as early as possible, starting from the requirement draft. It will save your time and money. Then defect cluster together. Like there is a very famous, if you google it, 80-20 principle. They say that 80% of the bug are being found in the 20% of the code. So for example, if you know that your system is complex, and maybe from your past experience you came to know this technology is new and system is bit complex, then maybe you can you come to know that developer will make more errors, or the bugs will be in this particular module. So like your many defects will come from this particular module, so you can prioritize your testing. So a small number of modules usually contain most of the defects discovered during pre-release testing. This is a very common testing principle, that our most of the defects, as I told you, 80% of the defect are found in 20% of the code, or is responsible for most of the operation failure. Only a small module or a small code sometimes is responsible for the bugs. Predicted defect clusters and the actual observed defects cluster in test or operation are an important input into a risk analysis and used to focus the test effort. Like as you know, exhaustive testing is impossible, so you need to cluster your priorities. You know, for example, this software module is safety critical, and this module is complicated and new technology, so it's quite possible that my developer will make some error here. So you focus your main testing, you try to cover as much as possible of this module. Then you defects, actually you know the problem could come from this module, and then you can cluster the defects. And then it's the basic principle of testing, that many of the defects actually are found in limited modules, not it is not divided over the whole code. The next is be aware of the pesticide paradox. What is the pesticide paradox? Pesticide paradox means, like for example, you are using the same test cases each time, and then maybe for the first time it will find 5 to 6 bugs in the code, but next time it will never find the bugs in the code, because it's a pesticide. Maybe you are familiar, like if you are using some sanitizers or even toothpaste, doctor recommend to change it after a few months, because your germs are used to that toothpaste or that germ killing, and now they are used to that, and like it will not affect them anymore. So this term is known as pesticide. Running the same test cases and again actually will reduce the chance of finding new defects. And then for example, you are writing some test cases for login functionality, and the code is changed, and you are still running the same test cases on the new code. It will not find the new defects. So this term is pesticide paradox. Just change your code, change your test cases, sorry, again and again. If same tests are repeated over and over again, eventually these tests no longer find any defect. That is for sure. You are finding a bug, you are reporting it to developer, he finds the defect or bug, fix it, give it back to you, and you are again testing the same code with the same test cases. Definitely this bug has been removed. It will not show any defect or bug. Change your test cases, add some more test cases to detect new defects. Existing tests and test data may need changing, and new tests may need to be written. Tests are no longer effective at finding defect, just as pesticides are no longer effective at killing insects after a while. Like insects are used to that material, and then it will not kill them. So in some cases, such as automated regression testing, the pesticide paradox has a beneficial outcome, which is relatively low number of regression defects. Like for example, if you are doing a regression testing, this we will see in upcoming lectures as well, that you have developed for your particular module some test cases, and then there is a different change. It was module 1, and you have like test suite, some test cases, we call it test suite 1. Then there was a module 2, and they both were communicating with each other. They developer made some changes in the module 2. Now you have to check that if the change in module 2 has impacted my module 1. For that you have to do a regression testing, that any change in the different module in module 2 will affect my module 1 or not. So for that case, maybe your previous test suite or your test cases will work in regression testing. But when you are testing this module independently, then you have to change your test cases, otherwise it will be pesticide. The sixth testing principle is testing is context dependent. Testing is always context dependent. Maybe for your mobile app you are testing in a different way, but for an automotive software you are testing in a different way. Testing is always not the same for each product. Testing is done differently in different contexts. For example, safety critical industrial control software is tested differently from an e-commerce mobile app. Maybe in e-commerce mobile app you have a different testing technique, but for a safety critical system you need 100% code coverage. You need to find the safety standards, you need to find everything. So that testing would be more intensive as compared to a normal e-commerce mobile app. So testing is always context dependent. You never apply the same testing technique or same testing principles on for example on the same on different softwares, but it's always context dependent. Another example, testing in agile project is done differently than testing in a sequential software development lifecycle. This we will see in chapter number 2. What is agile, what is sequential method, what is iterative method, it will see in detail. Then absence of error is a fallacy. Like fallacy mean like it's only a myth. If you say that there is no error in the code, is still it possible that your software is not meeting the customer requirement. It is also a kind of error. It is not validated. So some organization expect that tester can run all possible tests and find all possible defect, but principle 2 and 1 respectively tell us that this is impossible. You can never run all the test cases and you can never find all the defects. This we have seen in principle 1 and 2. Further, it's fallacy like a mistaken belief to expect that just finding and fixing a large number of defects will ensure the success of a system. That you found a lot of bugs, you fix them, and now you say your system is good. No, it's a myth, it's a fallacy. That means still it's possible there is no bug, but your system is not meeting the requirement of the customer. For example, thoroughly testing all specified requirement and fixing all defect found could still produce a system that is difficult to use. Like its usability is not good and difficult to use, so you can never say that system is error free. As per customer point of view, it contains some error, like it's not visible, it is like it is not good to use, it's not user friendly, that does not fulfill the user need and expectation, or that is inferior compared to the other competing systems. Maybe your system you have developed is you tested it, you found some bugs, fixed them, and now you say, yeah, my system is error free. It's not possible. It's possible that still your system is not meeting the requirement of the customer. So it is not, you can say there is an absence of error. So friends, this was everything from this video. We have covered the 7 testing principles. Now in the next video we will go to the very important topic of this chapter, which is about the test process, how the testing is planned and everything. So for this video it's everything. Until next video, I wish you a very nice day and take care.